Hello, my name is Samantha and I'm in 5th grade. This is my science fair entitled Pirouetting in Different Shoes Friction Experiment. Abstract. In this experiment, I'm trying to figure out which shoe helps you pirouette for the longest time, relying on the material that is on the bottom of each shoe. I tested this by doing 10 pirouettes on each shoe and used a timer to see how long I was turning for. When I was done turning and the timer ended, I recorded the time on a piece of paper. Once I do each shoe 10 times with all the times written down, I find the average time of each shoe. The average times will determine which shoe was the worst and which were the best. In result, the tap shoe was the best and the rubber boot was the worst. Question. How does the friction of shoes determine how long a pirouette lasts? What is a pirouette? A pirouette in French means to whirl about. It is a ballet turn in place on one leg. A pirouette is what you would call a 360-degree turn, spin or turn on one leg. If you just do one pirouette, it is called a single turn. If you do two in a row, it is called a double turn, which is 720 degrees. There are 3 types of pirouettes. I will demonstrate and describe each of them to you. Pirouetting en dehors, meaning turning outwards. The dancer's body turns towards the raised leg. Pirouetting en dedans, meaning turning inwards. The dancer's body turns towards the supporting leg. And lastly, pirouetting à la seconde. This pirouette is commonly seen in men's variations. Pirouettes can be done from multiple ballet positions, as in 2nd position, 3rd position, 4th position, and 5th position. 4th position is the most common pirouetting starting position. 4 and 5 pirouettes are most commonly performed, and up to 14 have been executed by 20th century dancers. In this video, I was in socks, I was on carpet floor, and I did a double turn. In the experiment, my pirouetting was en dehors, and this is a video of it. The experiment. Materials: ballet shoes, tennis shoes, tap shoes, jazz shoes, winter boots, rain boots, wood floor, and timer. Procedure. First, I give each shoe 10 pirouettes. The timer starts as soon as I push off and start turning. The timer ends when I stop turning. Once I stop spinning and the timer ends, I keep track of the pirouette time on a piece of paper. When I'm done doing all 10 turns on each foot with all the times tracked, I find the average time of each shoe. Whichever shoe has the most seconds and the highest time wins. Some variables I'm keeping in mind while doing this experiment. Same floor, same amount of pressure, same amount of clothing on each turn, same kind of pirouette, and the same starting position. Hypothesis. I think I will pirouette for the longest on the tap shoe and pirouette for the shortest on the rain boot. Hypothesis support. I think the tap shoe will have the longest time because there is a very smooth tap at the bottom of the shoe. Therefore, there is less friction that will be stopping me from pirouetting. The tap will make a great smooth surface for people to pirouette for a while on. I think the rain boot will have the shortest time because the bottom of the shoe is made of thick rubber. This will create lots of friction and it will be hard to turn on it for a while. The experiment. This is all my data. And there are all the times tracked with the kind of shoe that it was on, and there's the average. Here's a bar graph listing each of the shoes and their times. Result. The tap shoe came in first with 2.136 seconds. The jazz shoe came in second with 1.559 average seconds. The ballet shoe came in third with 1.481 average seconds. The winter boot came in fourth with 1.243 average seconds. The tennis shoe came in fifth with 1.124 average seconds. And the rain boot came in last with 1.061 average seconds. Conclusion. In this experiment, I learned that the materials at the bottom of shoes affects how long they can pirouette for. I think it was a trend that the shoes that were either softer or smoother, like the ballet shoes, winter boots, and tap shoes, made a longer turn. This is because they didn't have much friction, which is caused by being rough on the bottom of the shoe, so the turning time was longer. On the other hand, the shoes that had thick rubber, like the rain boot, stopped the spin from happening. There were too much drag and friction between the floor and the shoe, so it just stopped. Shoes like the tennis shoe are made to have at least some friction to be able to run. You can see all the lines with friction on the bottom. That friction slowed down the pirouette. The jazz shoe bottom was made of thin leather that was easy and soft to spin on. You can see here the super thin leather at the bottom of the shoes. In conclusion, there are many different materials at the bottom of different shoes. Because of the friction, some of them benefit you to pirouette better and others are a disadvantage. This is my bibliography. And here are some questions. Question 1. What interests you about this topic and where did you get the idea for your project? Well, I'm a dancer, and at my studio we do many different kinds of pirouettes on all different kinds of shoes. I always have a different turning time for each shoe, so I wanted to just find the final conclusion of which shoe helps me pirouette for the longest. This inspired me to do this experiment. If you had to do it again, question 2, if you had to do it again, what would you change and what improvements would you make? I would want to do different starting positions, some more different shoes, maybe some more surfaces besides hard floor. I think that'd be a good experiment. Question 3, what did you learn about the science behind your project and during the experiment? So, I learned that the smoother or softer surfaces, the faster you can go. Compared to a bulky or rubbery surface, you go a lot slower. Thank you so much for listening and for this opportunity. I hope you learned a little bit more about pirouettes too.